It's Peep Code. In the next hour, you will become familiar with the Vim text editor. Vim was specifically built to help programmers edit text more efficiently. Because of its origins in the terminal, it can be daunting at first, but with a little practice, you will find it well worth the effort. I think you'll find that it's not as hard as it looks. Once you've grasped two main concepts, it will all make sense. Learning the piano is also said to be worthwhile, but only if you play music. How do you decide whether learning Vim will pay off for you? Well, here are some areas where Vim really shines. It's on every platform. It's entirely keyboard-driven, though you can use a mouse if you want. It's precise. You'll feel like a text surgeon. It's powerful. You can make sweeping changes with just a few keystrokes. Unlike some other editors, those keystrokes won't strain your fingers. It works very well over SSH, even from an iPhone. It's highly configurable. You can extend it with plugins to do exactly what you want. If you use MacVim on macOS X, many standard keyboard shortcuts will work as you expect them to right out of the box. The documentation is excellent. Finally, you'll build skills that you can use for years or maybe even decades. Lighthearted feuds between users of various text editors are well known, but we sincerely want you to use the editor that you find most comfortable. Here are some areas where Vim is suboptimal. Many of its defaults are not what you want. Fortunately, that's easy to fix. Its scripting language is not a full-blown language like Ruby or Lisp, but the clunky Vim script. You can work around this to an extent with the Ruby interface, but it does put an upper bound on the sophistication of things like indentation logic. It is sometimes too easy to perform destructive tasks, such as overwriting the paste buffer. Its default regular expression syntax is inconsistent. Of course, there are other great text editors out there, including TextMate and Emacs. The writers and editors of this screencast have done time with all three, so we'd like to think we could go a full 12 rounds for or against any of them. It doesn't really matter which one you choose, but you'll benefit most if you pick one and master it. If you're currently undecided, this screencast will help you figure out whether Vim is the best one for you, or you might steal some of Vim's best ideas back to your editor of choice. And TextMate devotees will benefit too. When it's time to edit your Linux server settings, Apache configs perhaps, you'll have the knowledge and confidence to fire up Vim and get it done stat, so you can return straight away to the comfort of that gorgeous TextMate GUI. Vim started life in 1991 as Bram Moolenar's improvement on Bill Joy's venerable VI editor, which itself began back in 1976. The name Vim comes from VI improved. Bram still leads Vim's development today, almost 20 years later. And few open source projects have been actively developed for this long or with this continuity, and it shows in Vim's stability, speed, documentation, and community. Now, Vim is charityware. It comes for free, but you're asked to consider donating to the Kabale Children's Center in Uganda. You can find more details on Vim's website. In this screencast, we'll cover a lot of content in about 1 hour. Don't try to remember everything the first time. It's probably enough to just watch the various keystrokes pass in front of your eyes so that you know what Vim is capable of. Later, you can revisit specific topics or follow along in your own copy of Vim. And as always, use the pause button if you need to think about a topic or take a break. Vim looks complex, but is built on only two simple ideas. Once you've grasped them, everything else will fall into place. These two ideas are also the ones that distinguish Vim from most other text editors. The first idea is modal editing, and the second is operators. Vim is all about editing text efficiently. Have you ever thought about how you write code, or any text for that matter? You spend more time moving through existing text and editing it than you do typing fresh blocks of the stuff. so it's sensible to make navigation and editing as easy as, or even easier than, typing it the first time. And this is what Vim does. Most software prioritizes text input over editing. When your cursor is in the right place, you just start typing. Every word processor works this way. If you want to cut and paste, or search, or change a word, you have to pull down a menu or use some combination of modifier keys. Vim turns this on its head. It knows that you spend more time editing than performing data entry, so it makes editing and navigation just as easy as, or perhaps slightly easier than, typing text from scratch. As an example, if you want to move down a line or jump to the end of the document, you do it with a single key like J or G. And again, in the pursuit of efficiency, the things you do most often are on the home row of the QWERTY keyboard. There's rarely a need to move your hands away from the touch typing position to move the cursor. So how does Vim know what you mean when you press J? Should it take you down one line or type the letter J in the text? It depends on the mode. Pressing J in command mode moves the cursor down a line. Pressing the same J in input mode adds J to the text. This may sound confusing, especially when you hear there are 5 main modes: normal, insert, visual, replace, and command line, and actually there are a few others too. If keys behave differently in each mode, how is anyone supposed to remember all those combinations? The big insight here is you can ignore all the modes. Don't worry about them. Just think about this instead. You simply give Vim one command after another. For example, move down 3 lines, go to the opening bracket, insert some text, find the next opening bracket, and so on. That's it. Some commands are self-contained, such as delete the character under the cursor. Vim knows what you want to do as soon as it sees the command. For other commands, you need to tell Vim when you're ready to go. For example, if you insert some text, Vim doesn't know whether you're intending to type all 1,200 pages of War and Peace or just write Hello World. You have to tell it when you've finished. So when you're getting used to Vim, think to yourself, command, 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 and you'll be fine. You know this is what Vim wants because it starts up in command mode. And indeed, command mode is more commonly known as normal mode. You may be thinking, this is all very efficient, but how do I actually type in my code? It's a single command, I. This letter tells Vim you want to insert some text. When you're done, hit escape to let Vim know you've finished. You'll find you use escape a lot because it always takes you back to normal mode, ready for the next command. Vim has many motion commands, which we'll cover in depth later. If you currently move your cursor with the arrow keys, page up, page down, or home end, you're in for a treat. With Vim, you'll be able to move your cursor quickly and with far more precision. But even better, you can change the text while you're moving over it. This is a powerful workflow that you'll use all the time. Here are 2 examples. To delete from the cursor to the end of the line, type $, D for delete, and $, to continue editing all the way to the end of the line. To change all the code from the cursor to the second occurrence of end, type this: C for change, 2 for the second match, /end, return to search for the word end. Type your new code, then hit escape to resume command mode. It may look cryptic, but you'll find it makes more sense when you use it. In these examples, the D and C are operator commands. When an operator command is followed by a motion command, it tells Vim you want to operate on the text while you move over it. Operators can delete or change text, copy it, format it, or change its case, indent or outdent it. They'll feel more natural as you get used to the various motion commands. Which brings us briefly to Vim's extensive help system. To get help on any command or topic, use :H and a term to search for. To exit, type :BD for buffer delete. Vim's help system is extremely useful when you're starting out and is even useful for experts. In Vim, the keyboard is king. You won't find menu items or toolbar buttons for operators. but there can be a lot of keys to remember, so Vim tries to help you. The first convention is that uppercase commands are usually supersized versions of their lowercase counterparts. Lowercase I inserts text where the cursor is. Capital I inserts text at the start of the line. Lowercase w moves the cursor forward one word. Capital W treats contiguous code as one word and jumps forward to the next meaningful code word. Another convention is the forceful exclamation mark. Adding an exclamation mark to the end of a command will force it to happen without confirmation. To quit Vim, type Q, but Vim won't quit if you have unsaved changes. Force it to quit without confirmation by adding an exclamation mark. As always with Vim, it's all about efficiency. The most commonly used commands are placed on the home keys and have the best mnemonics. By the time you get to less frequently used commands, all the good mnemonics have been taken, so their keys become slightly harder to remember. For example, moving the cursor is a common task, so these are under the strong fingers of the right hand. You'll delete frequently, so the sensible D deletes. Slightly less obvious, the code folding commands all begin with Z because it looks like a folded sheet of paper. Well, that's enough theory. There's no substitute for using Vim, so let's install it and put it to work. Vim is available on Unix, Mac OS X, Windows, and other operating systems. Refer to the Vim website for a full list of downloads. When producing this screencast, the latest stable version of Vim was 7.2. There's an excellent port of Vim 7.2 for Mac OS X called MacVim. It's available as a universal binary. We recommend getting the latest snapshot release because the latest stable release is more than a year older. Be careful. There are two different ports called MacVim. The best one is a Google code, not macvim.org. Download the application, uncompress it, and copy it to your applications directory. You can also build it from source if you want to. There are good instructions on the website. Once you've installed MacVim, give your shell the good news. Copy the bundled mvim shell script to a directory in your path. We also recommend that you symlink Vim to it as a shortcut if you want to run the latest Vim in the terminal. So if bin is in your path, copy and link it with these commands. Then in your terminal, you can fire up MacVim with mvim file name or the GUI-less Vim with Vim file name. Finally, spread the love to tools like crontab and getrebase-i by setting up your shell's editor variable, probably in the .bashrc file in your home directory. Be sure to point editor to Vim, not mvim. Vim is probably already available on your system, but it might not be the latest version, or it might not have been compiled with the features you want. Compiling Vim from source is both easy and the best way to go. Download the latest version and unzip it. Vim has many optional features which can be compiled in. To make things easier, they're grouped into feature lists: tiny, small, normal, which is the default, big, and huge. Unless you're running on a puny system, I recommend treating yourself to the huge list of features. You do this in the configure step. You can also compile in Ruby support and Perl, Python, and Tcl support. This doesn't affect whether or not you can edit Ruby files in Vim. Instead, it allows you to run Ruby commands within Vim and to script Vim with Ruby. By default, Vim will install into user local. To install it elsewhere, specify with the standard -- prefix flag. Now you can build Vim with the standard make and make install. Experts can fine-tune which features are compiled in by editing the makefile instead of specifying a feature list. You can see the full list with the -- help flag. To verify success, type vim -- version. You should see the version number and a long list of enabled or disabled features. On Windows, the best option is to install a pre-built binary for gvim, the graphical version of Vim. Go to Vim's Downloads page and get the self-installing executable named gvim72.exe or similar. Double-click the file to start the installer. It's a good idea to tick the box labeled create.bat files for command line use. If you use a 64-bit version of Windows, you could follow the instructions at the Google Code project. Cygwin users can get hold of Vim through Cygwin's installer. Once you've installed gvim, use gvim rather than vim on the command line. Let's start by taking a tour through the bare essentials of Vim. Vim is often the only decent editor available on remote servers or shared hosts. By the end of this chapter, you'll know how to use Vim to make basic edits, which is sometimes all you need. In future chapters, we'll cover configuration and show you the skills needed to use Vim as your primary editor for development. We'll assume the Vim on your server is au naturel, that you've not configured or customized it at all. This means we'll configure some basics as we go along. Later on, we'll build a comprehensive configuration file. Our task in this section will be to add a server alias to our website's virtual hosts in Apache. If you want to follow along, you can edit a similar file from the code download at Beepcode. We'll cover file browsing later, but for now the easiest way to edit a file is to type vim-N file name. This brings up Vim in the console with example.conf. The -N argument is rather important and means not compatible with VI. Vim can run in two ways: compatible with VI, which is pretty limited, or not compatible, which is the whole point of using Vim instead of VI. Vim starts up in compatible mode unless you've configured it in a .vimrc file or have instructed it not to with -N. So what are we looking at? Any space between the end of the file and the bottom of the console is marked with tildes in the first column. The cursor, top left, is a block because you start off in normal mode. Vim comes with syntax highlighting for over 500 file types. If you're looking at a mass of black or white text, it's because your Vim hasn't been configured to deduce the syntax automatically. For now, we'll set a few variables to tell it we want syntax highlighting. And this is an Apache file. We'll also tell Vim to handle multiple files better with the mysterious hidden option. The colon feeds long-form commands into Vim. As you type, you'll see them in a line of text at the bottom of the window. In future chapters, you'll learn how to set personal shortcuts for commonly used commands. The top of the file looks like this. We want to add server alias www.example.com just below the server name line. The most basic way to do this is with this sequence. J moves the cursor down one line. O opens a new line below the current line, ready for new text. Escape reactivates normal mode. It's been said several times that Vim is all about efficiency. It's not very efficient to retype words that are already in the document. Here's a more efficient series of steps, such as would be performed by an experienced Vim user. Press U a few times to undo the changes you just made. We'll copy the server name line and tweak it. First, the copy. YY copies or yanks the current line, and P pastes below the current line. Capital P pastes above the current line. Alternately, you could use capital Y instead of lowercase yy. Second, tweak it. change the whole word server name to server alias. Or we could move the cursor to the N and change from there to the end of the word. Here are 3 ways to move from the S to the N. You could move forward 1 letter at a time. You could prefix the motion command with the number 6. Or you could jump forward to the next instance of N. Now that the cursor is on N, the text up until the end of the word can be easily changed. Finally, we need to prefix www. Onto example.com. Here are 2 ways to do this. Move forward 1 letter and append text. Or jump to the next word and insert text. Excellent. We've added our server alias. Let's save or write the file. If the file is read-only, Vim will complain. Here are 3 ways to get around that. You could use the $W exclamation mark to override the read-only flag without confirmation. But if you don't have permission to write the file, you could write the file somewhere else and copy it back. However, we're professionals. So let's use the Unix sudo T idiom. Note the space after the W and before the exclamation point. The exclamation point executes a shell command and % expands to the current file name. So this writes the file with sudo privileges. What have we seen so far? Basic motion. Using a count with a motion command. Copying or yanking a line. Pasting below or above the cursor position. Inserting text before the cursor position and appending after. Jumping forward to a given character on the current line. Jumping forward 1 or more words. Changing 1 or more words. Undo and redo. Writing a file. Quitting. Let's take those ideas and apply them to a longer file or to several files. Suppose we've just upgraded Passenger from 2.2.8 to 2.2.9 and need to configure it to use the new version. Edit this file in an existing Vim session by typing the path to the file. Search for the version number with /2.2.8. This puts the cursor at the start of the match. Jump forward to the 8 with F8 and replace it with R9. To find the next match, use the single letter N as often as needed. To go back to the previous match, use capital N. We can make things easier for ourselves by highlighting the matches. To highlight matches from the last search, do set HL search. And to highlight matches as you type in a search pattern, do set ink search. But there's a higher level concept here. I want to do a search and replace. The mnemonic is substitute. This looks like a regular expression and works like one. Where colon signals the start of the command, %s means substitute across the whole file, and / delimits the match and the replacement. You can append several flags to this command to fine-tune its behavior. The 2 essential ones are G, meaning global or every match in the document, not just the first. C, meaning confirm, or else Vim will ask you before performing each replacement. Beware that in a regular expression, the period matches any character. For precision search and replace on a literal period, escape it like this. Instead of searching, you might find line numbers are easier to work with. To show line numbers, do set number. You can go to the 12th line with 12 capital G. You can use GG to go to the first line of the file and capital G for the last. Now let's return to our virtual host file and copy some configurations across from another host's file. Let's change Vim's working directory to our Apache configuration directory. Now you can check the current working directory with pwd. Now it's easy to open up example.conf and myotherapp.conf. Or you can type e dot to view a directory listing that can be navigated with HJKL or any other technique you've learned so far. Hit enter to edit the file under the cursor. I want to copy the asset expiration stanza from myotherapp.conf to example.conf. There are many ways to select text. The easiest way is with visual mode, where Vim highlights the text as you select it. This technique does a line-wise copy, so it doesn't matter where in the line the cursor is. Capital V puts us into line-wise visual mode, copying entire lines instead of sequences of characters. To go into character-wise visual mode, use lowercase v instead. As mentioned previously, capital P pastes text into a spot behind the cursor in character-wise mode or into the previous line in line-wise mode. Text can be deleted in visual mode too. Select the text and hit D. The deleted text is written into the paste register, the same as cutting text to a clipboard. To change text selected in visual mode, use C as before instead of Y or D. If you want to save these changes to the new file, use W or one of the other tricks mentioned previously. You now know how to fire up Vim in its useful state, -N, browse a directory, open files, and turn on syntax highlighting. You can navigate simply, search for text, and substitute with a regular expression. You can select arbitrary amounts of text, copy, delete, or change it, and paste it elsewhere. You can save your changes or throw them away. One other command is worth knowing right from the beginning. Period repeats your last change. Unfortunately, it doesn't repeat command line changes prefixed with a colon, but it works for all other edits. You'll find that you will use it often. If your goal is only to edit the odd configuration file, you're fully equipped. But in the next few chapters, we'll charge into Vim and learn to configure it and use it for development. Before we go any further, we'll configure Vim with some sensible values. Some of Vim's default settings are less than ideal, so it's worth knowing how to change them by editing a few files. But talking about them as mere files, as letters that form words, trivializes their significance. Your Vim configuration is a living document, now in its infancy, soon to mature into an intelligent, charming, humorous sidekick with a penchant for eating vegan beef jerky after midnight. The Vim configuration files that you create today may stay with you for the rest of your life. On your deathbed, you will pull a floppy disk from its sheath, hand it to your children, and say, "This is my life's work, suitable for editing all manner of text files in extreme comfort." Now, in all seriousness, your Vim configuration files, properly organized, can be used on any machine, whether graphical or terminal-based, and many people do enhance them for years and years. A vanilla installation of Vim is a useful text editor. Your configuration files turn it into your text editor. Before we even begin, let's talk about storage. I hope it doesn't need to be mentioned that you should keep them under some kind of source control. The files in question will be the .vimrc and .gvimrc in your home directory. You'll also build up a .vim directory with more extensive third-party configuration files and templates. Two strategies are worth considering. First, you could store all your Vim-related files in your home's bin directory, then symlink them to their spots in your home directory. Or you could keep them all in the .vim directory and symlink the vimrc and gvimrc to their proper locations. However you do it, you should make a habit of checking files in regularly and pushing them to a server. Not only will it give you an instant backup, but you'll also be able to clone them to any new machine you work on. Before creating configuration files, let's look at a few conventions. Vim has many options which can be queried, set, or reset with the same pattern. The list option shows tabs and end-of-line characters. It is a Boolean. Options with numeric or string values, such as soft tab stop, work similarly. This option sets the number of spaces to insert for a tab. Experienced Vim users don't type out soft tab stop. That's not efficient. They use abbreviations such as STS. Almost every option name has a short form which you can use wherever you would use the full name. One of the most frustrating parts of any configuration system is figuring out which file was responsible for setting the current value of an option. Perhaps a plugin is overriding the value and you need to find the culprit. Using the verbose command when querying an option's value will tell you where it was set. The only caveat is if the option was set by hand or hasn't yet been set. In those cases, there won't be a last set message. You might be wondering how you know what options are available. Typing options will bring up Vim's options screen, which shows all of the options grouped by area. You can see every option's name, short name, brief description, and current value. You can easily jump to an options documentation or update its value on the spot. You can also see all options differing from their default values with set. Vim configuration files are simple sequences of commands, just as you would run them in a live session. Just omit the colon. Vim will read your configuration files at startup. We've provided a simple one for you in the code download at PeepCode. If you're running Vim in a graphical application outside of a terminal, such as MacVim or GVim, you can configure graphical options in a .gvimrc or _gvimrc file. We've provided one of those too. Finally, you can configure Vim on a per-document basis using mode lines. These look like this. They must come within the first or last 5 lines configured by the mode lines option of a document. Typically, you would use mode lines for one-off files where it's not worth defining a whole new file type. Whenever you open a file, Vim tries to work out what kind of code it contains and set itself up appropriately. If you open a Ruby file, Vim sets the shift width to 2 spaces. Opening an HTML file will set the shift width to 4 spaces. File types can have syntax highlighting rules, indentation rules, and plugins, which set up much more complicated behavior. You can alter or add to the behavior of any of the 500 or so predefined file types or define new ones of your own. Type help file type to get the full details. As a quick example, let's update Vim's HAML support. Tim Pope maintains the HAML files on GitHub, so clone the repository and copy them into your local Vim configuration directory. Quit Vim and restart it to pick up those new files. How do these HAML files work? In the ftdetect directory, it stores the logic for detecting HAML and SAS files. In the ftplugin directory, it stores the commands to execute when a HAML or SAS file is detected. Finally, the indent and syntax directories contain the indentation and syntax definition rules. Syntax definition files tell Vim about the features of a language or template. Comments, keywords, variables. Color schemes describe how these elements should look. Vim ships with a few, or you can add your own. A popular scheme is Vivid Chalk, which not entirely coincidentally looks like a certain macOS X editor's Vibrant Ink scheme. To install it, create a colors directory in your .vim directory and copy the vividchalk.vim file over to it. You can sample it by issuing the color scheme Vivid Chalk directive interactively, or put the same command in your .vimrc without the colon. Now is a good time to copy the example configuration files into your home directory if you haven't already. Next, we'll look at an area where most text editors are awful: navigating files and directories. Most programming tasks involve working with several files, and sometimes dozens or even hundreds. First, you need to find them. Then you need good ways to arrange them in your Vim window. Vim is very capable when it comes to arranging windows. There are many third-party plugins for opening files and switching between them. Finding and opening files is, oddly, the Achilles heel of most text editors. Indeed, you wouldn't choose Vim over any other text editor simply for its file-finding capability, but nor would you abandon it. People like to look for files in many different ways. If you're a visual sort, you want a hierarchical view of your files. If you're a words person, you prefer to pull up files directly by name. Most of us lie somewhere in the middle. Although Vim's own file finding is basic, there are at least half a dozen good plugins spread out across the visual textual spectrum. Your challenge is to find the one that suits you best. Vim always has a working directory. You can see its current value with the pwd command and change it with cd. You'll generally want it to be the root directory of your project, but you can have Vim automatically set its working directory to the current files directory with set auto chdir. Or check out a plugin we wrote while working on this screencast. The Vim Router plugin looks up through parent directories for a .git directory and uses that as the working directory for the project. To edit a file, type E. You can tab complete file names just like a shell by putting set wild mode equals list : longest in your .vimrc. The up arrow works as you would expect. Just type a colon and hit the up arrow to see the last command. If you pass a directory name such as app models, you'll get a directory listing that you can navigate with all of Vim's motion commands. You can alter the listing style with a few keys. You can also open files, delete files or directories, and do other tasks. You can use the exact same file management commands to edit remote files. In practice, I prefer to connect to an SSH server with plain SSH and then run Vim locally. Here's a tip. When you're editing code, gf, go to File, edits the file whose name is under the cursor. Plugins like Rails.vim customize this further to, for example, find partials, so it's a useful command. Navigating between files on disk or within a project is, surprisingly, underserved by the default features of Vim. Fortunately, third-party plugins make it a bit easier. I'll show you 4 different plugins, 2 visual and 2 textual. First up is the Nerd Tree. This is the closest you'll get to TextMate's drawer, showing your files and directories in a tree. It ships with many key mappings to navigate and manipulate the tree, all customizable, and you can show and hide the tree at will. Naturally, you don't need to take your hands off the keyboard to do any of this. Often, though, you don't need to see every last file in a tree. Sometimes the files you do want to see are scattered across several locations. In these cases, you might prefer the project plugin. It is a bit more work to set up, but once there, you see exactly the files that you want. You manipulate and navigate its tree with Vim's folding commands, so you don't need to learn any new keystrokes. We'll look at standard folding a few chapters from now. See the PDF included with this screencast for a link to a quick overview of the project plugin. It's worth noting that the Rails.vim plugin integrates with both NerdTree and Project. Now let's look at the textual plugins. I prefer these because they are faster to work with and seem to be more, well, Vim-like. Lusty Explorer is both a file system explorer and a buffer explorer. We'll come to buffers in the next section. It uses fuzzy matching to pull up files even if you don't type the full name of the file. Emacs users may be familiar with it already. To activate it, type leader LF. We'll mention the leader in a few chapters. It's your custom shortcut key and is / by default. You'll see an unobtrusive prompt at the bottom of the screen. Start typing the name of the file you want to see, and Lusty Explorer will refine the match as you go. Hit Tab or Enter to open a match, or Escape to cancel. See the documentation for other commands provided by the plugin. Lusty Explorer is fast and efficient, but has one huge drawback. It doesn't recurse into directories. You have to tab into each directory and subdirectory to reach that file you're looking for. Adding this capability is on the author's to-do list, but most of the code is written in Ruby, and this could be your chance to add a useful feature to a popular plugin. This brings us neatly onto our favorite file finder, which was unshamedly inspired by TextMate, Jameis Buck's Fuzzy Finder TextMate plugin. It requires the Fuzzy Finder Vim plugin and the Fuzzy File Finder Ruby gem, so you'll need to install those first. Unfortunately, Vim doesn't provide any way to specify version dependencies, and different versions of these plugins have had compatibility problems. But fear not. As of this screencast, you can install a working combination as follows. Download Fuzzy Finder 2.22.3. Copy its contents to your Vim directory in .vim. Install the Fuzzy File Finder gem version 1.0.4. Copy fuzzy_file_finder.rb from the gem's lib directory into .vim Ruby in your home directory. This shouldn't be necessary, but it wouldn't work for me otherwise. Download Andrew Stewart's fork of Fuzzy Finder TextMate. Then copy it to .vim/plugin in your home folder. See the PDF that came with this screencast for exact URLs. Finally, add the mapping map leader t:/Fuzzy Finder TextMate, enter, to your .vim RC. Now you can hit /t, type a few letters, and navigate right to the file. The matches are presented in an omni-completion window that can be navigated up and down with CN for next and CP for previous. Hit Enter to open the selected file. Once you've opened a few files in a Vim session, how do you arrange them on the screen? It goes like this. A buffer is a file that has been loaded into memory. The term window refers to a viewport into a buffer, not an application window as you may otherwise be familiar with. You can have as many buffers and windows onto a buffer as you like, and you can tile them horizontally and vertically to your heart's content. What's more, you can do all this on a tab-by-tab basis. Some people love tabs, but I never use them. For me, a good grasp of window commands and an efficient buffer explorer do the job better. I'll show you how to work with windows and tabs first, and then we'll look at buffer management. You'll be pleased to hear that all the window commands are easy to remember. They all start with Ctrl-W and end with an obvious letter that corresponds to the task. When you edit a file, it's loaded into a buffer and you have a single window onto that buffer. Now I want to look at two different parts simultaneously, so split the window horizontally, Ctrl-W, S. The two windows are independent and you can scroll them separately. To move to the bottom window, type Ctrl-W, J, and to move up, type Ctrl-W, K. Use capital J and K to move the windows themselves to the bottom, Ctrl-W-J, or top, Ctrl-W-K. Now we want to split the window vertically, Ctrl-W-V. You've probably anticipated how to jump between vertical windows, Ctrl-W-H and Ctrl-W-L, and how to move the windows to the left-hand side and the right-hand side, Ctrl-W-H and Ctrl-W-L. Actually, the vertical split doesn't look so good, so close it again with Ctrl-W-C. There are a few more ways to move the cursor to other windows. Ctrl-W-W cycles through them anti-clockwise. Ctrl-W goes clockwise. Ctrl-W-T and Ctrl-W-B moves to the top left and the bottom right windows respectively. And Ctrl-W-P moves to the previous window. Similarly, there are several ways to move the windows themselves. Ctrl-W-R and Ctrl-W-R rotate them anti-clockwise and clockwise respectively. Ctrl-W-X exchanges the current window with the next one, and Ctrl-W-T moves the current window to a new tab. It's so easy to open up windows all over the place that I often go a little overboard. When this happens, I use Ctrl-W-O to make the current window the only one. Many commands, but all easy to remember. When you open or close windows, Vim resizes the others. You can configure how Vim does this, as well as resizing windows as you go. Look at the documentation for details. A tab holds one or more windows. Most commands work on a per-tab basis. Like the window commands, the tab commands are easy to remember and do what you would expect. To keep this brief, here's a list. Although easy to remember, they're a bit much to type, so we've included some helpful mappings in the example.vimrc file. It's crucial to know how to navigate your buffers quickly. Like finding files, Vim's own buffer navigation is passable, but you'll want a specialist plugin on top. You can list all the buffers with ls. The first column shows each buffer's unique number, which won't change while Vim is open. You can always go to, say, buffer number 3 with B3. The second column shows the buffer statuses with various flags. Plus means a buffer with unsaved changes, while equals means read-only. Percent is the buffer in the current window. Go to the next and previous buffers with BN and BP, and close a buffer with BD, buffer delete. BF goes to the first buffer and BL the last. And you can open a window for every buffer with the BA command for buffer all. One of the more useful commands is Control-Caret, which edits the alternate file. Generally, this is the last file you edited, so it's handy when you nip into another file, perhaps with GF, to check something. You can nip right back again with Control-Caret. Some plugins, like Rails.Vim, set up useful alternate files so you can quickly jump to, for example, a model's test. The only buffer commands I use are ls and bd. The rest of the time I use a plugin to work the buffers. There are various buffer management plugins, including Lusty Juggler, which puts your most recently used files on the home keys, and the Fuzzy Finder plugin mentioned above, which matches buffer file names. But my favorite is Buffer Explorer. It's fast, unobtrusive, and useful. Once installed, hit \BE to open the Buffer Explorer window. You'll get a souped-up list of your buffers which you can navigate with the usual motion commands. When the cursor is on the buffer you want to edit, hit Enter to open it. The Buff Explorer will close automatically. To close a buffer, hit D. By default, the buffers are listed in most recently used order and show full file paths. You can easily alter every aspect of the list either interactively or in your .vimrc. As an example, switch to relative paths with capital R while exploring, or configure it in your .vimrc with this line. You can close the Buff Explorer window at any time with Q. Tags are cross-editor file format for mapping classes and methods to file names. Some people like to navigate code with tags. If this is you, you'll be pleased to hear Vim has considerable built-in support for exuberant C tags and cscope. In fact, the top-rated and most downloaded Vim plugin on the Vim website is TagList, which turns Vim into a fully-fledged source code browser. See the website for more documentation on tags.